learn how to add fractions. I'm sure you know that very well. We'll start with a very simple problem. Evaluate the following, leaving your answer in the simplest form. So let's look at diagrammatically how this works. 2/5, like this, 2/5, obviously two rectangles, 2/5, plus 1/5, I do it in different color. And the boxes are exactly the same size, or you can call them cell, just like Excel, they're called cell. And if you add them, obviously, they just fit well, right? Because they're the same box size. So two green box plus a red box gives you 3. So obviously the answer is 3 out of 5. So that suggests to you the 5 has a meaning. Oh, do I add 5 of size 10? No, no, no. The 5 is like the size, it's like how many containers altogether. And the 5 containers, 2 is filled with water. The other container, 5 containers, has 1 filled with water. So if you add them, there's 3. Does that make sense? So now you know, oh, you only add the numerator. And you remember that because you remember that diagram. You remember because you wouldn't go like, oh, 2 plus 1, 3, 5 plus 5, 10, 3 out of 10. Like, you just don't add anything. You got to, just like when you play soccer, do I just kick the ball? Oh, obviously, but you don't want to kick your own goal, right? You know what I mean? So you got to really common sense, understand the rules, understand why. So yeah. All right. So now there's another 2 questions. Do I need to draw a diagram? Probably not, because like life's too short to draw so many things. Once you know the rule, just apply it. 5 plus 7 is 12 out of 16. You do have to simplify, which you know how to do that. Divide by 4 is 3, 4. Okay, do you have a question, Harrison?
Oh, no.
Stretching, I'm just stretching. That's fine. 3 plus 2 is 5 over 4. And you just go 1 like that. Cool, is that right? Cool. Yep. Oh, what if I do a whole plus a fraction? Whole, like, oh, what's whole? Okay, well, means there's no empty boxes, right? Just 2 whole. All right. Actually, you know what? That's where you use the highlighter. Yeah, I forgot about it. Highlighter is quick. Watch this. That's why maths is fun. You get to do everything. No comment, please. And then this, it actually straightens up. Oh, very smart. Okay, cool. 2, that's 2. Look, watch. I'll do a color effect. Look, that's 1/3, right? See 1/3? 1/3. How cool is that? Now watch this. I haven't finished yet. I haven't finished. 2 plus 1/3. Oh, what would that be? 2 1/3, right? Because they just don't interact that well. Like that's the mix. That's why it's called mix, right? It's a mixture. They just remain to be a mixture, right? So you got the 2, the whole, and 1/3 become 2 1/3. Duh. You know what I mean, right? Get it? All right. So you don't need to do anything special if it's a whole plus 1/3. That's pretty cool. Again, that's good. All right. Let's move on to the next bit. Oh, so what do I do? So just like the diagram. Now watch this. You do the whole separately. Does that make sense? And the fraction separately. Some teacher would say, not that I disagree with them, oh, just change or always change to improper fraction. But in this case, I think it's better that you do it separately because it's quicker and less work. 3 plus 2 is 5. 3 plus 1 is 4 over 5. How cool is that? What if it's a mixed fraction? You just carry over. But you'll see example of that very soon, I think. So for example, what if, actually I've got enough space. So you go, what if the question was 4 out of 5 plus 2, 3 out of 5? Well, you do the same thing. Watch this. Do the same thing, but you will see you get 8 out of 5, but you can't write this. That just doesn't make sense. I mean, it makes sense, but it's not. It's like saying, this guy have no manners? Like, do it properly. Just do it. So that's 8 out of 5. So you get something carried over, 1 and 3/5. So the 1 and the 5 gets combined, 6. So can you write this example down? Because you say, oh, it's good But what if he went over? Well, that's what you do. Say again. 7. Oops, made mistakes. That's okay. It's okay to make mistake. It's not that, oh my God, I made a mistake. So then correct it. What's so bad about it? Like 7, that's 2. And then that's actually, oh my God, so many bad. Okay, do you know what I do? I get my student to rub off everything or just cross out, redo it again. It's no big deal. Oh, you never make any mistake in your own life? I'm sure. This guy's perfect. Oh, I can't write 5 properly. Seriously, you should use this stylus pen. It's really hard to write. It's not what you think. Okay, done. All right, any questions? All right, cool. Okay, ooh, what if the size of the container are different? See? Like, it can't just go, oh, something goes, oh, 2 plus 3. We're ignoring these two. No, it can't do that. Again, once you have the concept, it's very easy. Watch this. Some people have brains. Now, watch this. All right. Now, 2 out of 5. Obviously, you can't add the 2 and 3 because the box size are different. So that's 2 out of 5. Watch this. 2, right? That's 2 out of 5, right? Now, the other one's 3 out of 10. Now, obviously, the 2 and the 3 doesn't compare well, right? They are different sizes. That's 2, but it's much bigger than the 1. So what do? I make them the same denominator. Why? What does that mean by that visually? Means that because the size of the box is big, right? I could halve it. And when you halve it, so what does that mean by that? Let's watch this. Again, once you see the concept, it's just so easy. Watch this. That's equal to, look at the size of the box get smaller, right? So let's chop this in half so it become like this. So all of a sudden you get rich. Everything got double. But you haven't changed the value. It's still 4 out of 10, which is same as 2 out of 5, right? We did that before with equivalent fraction. It's still the same fraction, equivalent, but now you can add them because the size of the box are the same. Does that make sense? Yes? Now I could add them. Now they're all out of 10. Cool. Now they could come. So it's out of 10. So again, watch this. You just have to do it once. It's like when university lecturers, like, oh, you just have to prove that once. And after that, you just use the rule every time. And it's exactly what they do when you're at uni and you do the same thing in year 7. You just have to show once, you get it. You don't have to keep coloring boxes. You can start doing it in your brain without. So that's, what's that? 4 plus 3, oh, 7. Now, again, how do I show the work in your book? You don't have to draw a picture, but you can if you want to, if you've forgotten. So we make the equivalent fraction, right? We double, because doubling means the size of the box for half, but you have more boxes, 4 out of 10, plus 3 out of 10, oh, 7 out of 10. That's the working I wanted to show. You must show this working. A lot of people, oh, I just did it on my head. I did it on a separate piece of paper. No, show work in your book. That's all you have to do. Show work in your book. Harrison, what are you doing? Can you write it down? Did you write it down? You have to write it down. When I was a student, how did I go at maths, go at student? Because I just write down everything what the teacher write. Because every time I go home, I complain and say, my mom or dad say, no, did you pay attention? Oh, did you do the work? No, okay. So yeah, you know what I mean? So you have to write it down. You have to write it down. Did you write down everything? Yes, I wrote down everything. Did you do the practice? No, I haven't. I have to do practice. So you have to write everything down. What the teacher say, everything. All right, next question. What if they? Oh, that's actually a bit harder because the other one is just half the box. What if you can't, like, these two boxes, like, not the same size, and you can't just halve it, right? So that gets a bit trickier. So that's what you do now. Watch this. It's what we call the lowest common multiple, LCM. So how does that work? So now let's look at this again more carefully. We do that very detailed. Once you have the understanding, fraction becomes so easy. So that's 2/3 Oh, that's 2/3, no big deal. That's 1/4, no big deal, 1/4. Okay, now you can't add them, and that box is not half of that box. So what you do is you're going to make a lowest common denominator. In that case, it's 12. So I'm going to times the first one by 4. So what does that mean? When you times it by 4, visually speaking, means you divide each box, each giant box, into 4 boxes. Yes? So the value of the fraction doesn't change, but now it becomes easier to add. So it becomes 8 out of 12, means that every color box, you get 4 times as much, but now overall you got 12. Does that make sense? 8 out of 12. 8 out of 12, right? See this? 8 out of 12. Because I quadruple the number of boxes, right? Not only the shaded and the non-shaded. However, the second one is you triple the number of boxes. And in that effect, they end up with the same denominator, 3 out of 12. Oh, now the boxes are the same sizes. I could now add them together. Well, yeah, I love coloring. I think I won a competition. I won there's a policeman something, and then I entered the competition. I won a Game Boy. Do you know what that is? It's called Nintendo DS now. But it's a Game Boy. I think, oh my God. But you know the disappointing thing is that I forced my father to buy one before I won the competition. I didn't know there was a competition, but then I ended up having 2 Game Boy, so I ended up selling one. I said, oh, no, I sell it in some to other people as a second hand. You know what I mean? I make a loss, but it doesn't matter. But you never know. Good things could happen. I didn't know that I would win something. Oh my! You know what? It's so cool. But anyway, it was a. But then it's good. I was really good at coloring. I actually enjoy it. Yeah. All right. Good. Now watch this. Oh, what's that? Oh, hang on. I got carried away. Sorry by my own life story. Oops. Sorry about that. Let me just get more coloring. That's why I get bored with coloring. It just gets boring after a while. When you're young, when you're not good at anything, it's just like, just the coloring. That's the only thing I could do. After that, okay, I've got maths. I think that's more interesting. Okay, actually, not just because interesting. I was forced to do it because, like, in order to get respect from my parents, get good marks in math and English and everything, and you know what I mean. Otherwise, you have no. All right, what's that equal to? Actually, that's 11 out of 12. Okay, get it? Does that make sense? So once you have the visual concept, or when you make an equivalent fraction, it's same as doubling or tripling the number of boxes. And that's very powerful because what you see is not what you get, isn't it? You thought, oh, I'm actually getting richer, but you're getting richer, but everyone else getting richer. So you still haven't gotten rich overall. Does that make sense? It's like this. Equivalent fraction is let's make everyone rich. But if you make everyone rich, you still haven't got rich because it's not relative, isn't it? So if you double the denominator and the numerator, it's equivalent. But the good thing is that everything is equal. You can now add them together. I think that's how it works. Okay, next one. Now I have a conclusion. To add or subtract fractions with different denominators, we must first change them to equivalent fractions with the same denominator. And that's not hard because it's all LCM, lowest common multiple. All right, let's do some examples together. So we've got 3 examples remaining. We're going to go through them and I'll show you how it works. It's very easy. So the first one is, all you have to do is, 7 times by 7, right? And the other, the other one's 5. Does that make sense? That's how I get the equivalent fraction. So you look at this. I don't like to be cross multiply because it gives you the wrong impression. So it's just like, that's 7 times that by 7. That's 5 times that by 5. Does that make sense? So that's the working out I do. You don't have to do it, but I think it's safer for me. So 5 times 7 is 35 plus 20 out of 35. And then you get 41 out of 35. Oh, it's improper. Mixed fraction looks better. So 1, so what's that? 5 plus 1, 6. All right. Do I have to simplify it? No, because you can't simplify this one. It's already the simplest form. And when you see this, you won't usually there's no simplify necessary because the LCM they don't have any common factors when you do that. Okay, usually. All right. Any question? Again, I need to see this working. I don't need to see the pictures, but if you like drawing pictures, it's fine. But you must show this working. I doubt if anyone, even me, after finish university maths degree, I still can't. I could do that in my head, but it's actually a lot of work. But I'll encourage you to show full working. Now, next one. There's two ways. I'm going to show you both ways so you can understand. Okay, 6. All right, 6. That's 4. Pretty easy. The other one is, what's that? 6. Okay, that's pretty cool. Okay, so 18 over 24 plus 20 over 24 equal 38 over 24. Oh, you have to simplify. That's fine. Let's turn it into mixed fraction first. 38, 14 left, right? And then you simplify 1 and 7 over 12. Now, can you see you need to simplify? You can actually avoid that completely with the second method. What does the second method involve? Now, the second method is that you have to understand numbers. If you look at it, instead of just looking at, oh, this times it by 4 times it by 6, let's break it down. You don't have to do this, but I think it helps, right? But somebody can see that. So you can see that in this denominator, the 3 is missing, right, compared to that guy. And compare these two, you got 2 missing, right? You got 1, 2, but it's not enough. You need another 2. So instead of 4 and 6, you do 3 and 2 to get the LCM. Does that make sense? So you get 9 out of 12. And I'll guarantee you, no simplifying is necessary. It's much quicker. So what do you get? 19 out of 12, you still get exactly the same answer. I encourage you to go in this direction, but you don't have to, but it's actually more work. Does it make sense? Because you can compare 4 and 6, the LCM is 12. Why the 12? Because this one's got 3 missing, this one's got 2 missing. Any question? Yeah? Did you write it down? Brooklyn, did you write it down? Yeah. All right. You have to write it down. Okay, good. Good that you pay attention, but you have to write it down. Okay, next one. Oh, now remember this. How about adding mixed fraction? Watch this. Do exactly the same thing. 5 out of 6, 3 out of 4, right? Now, you don't have to break down into this because if the numbers are small, you can just do in your head, oh, 12, 2, right? The other one is 3. Yes? And then you get 2 plus 3 is 5, 10 over 12, 9 over 12. Oh, remember now, actually, we'll do the whole thing. 19 out of 12. I need you to show full working. And do it vertically. Some people, oh, I'm going to do horizontally. No, do it vertically. Does that make sense? That actually helps. So that's 1 and 7 out of 12. 1 plus 5 is 6, like that. Step by step. And you make, oh, why do I make silly mistakes in the exam? Because you rush. Stop making silly mistakes by not rushing. How come I have a car accident? Because he drove too fast. Don't, not rush. I remember I read, it's like on the news, they interview a very elderly man. He said he never had accident in his whole life. And they try to get his advice. He said, just take it slow, blah, and then blah. It's almost like he's showing common sense. I say he never had an accident. It was on the news. He was interviewed. How did you do that? Is it rocket science? No. Just drive slow, not too slow, but you just take it slow and just like follow your nose. I just think, oh, that's gold. Yeah. All right, cool. Now, can you do the work 6B today? Have a